Yes, hello everyone. Hello to all of you. Hello to all of you. Hello everyone. Everyone please confirm, am I audible? Am I visible clearly to all of you? Good evening, good evening, good evening to all of you. Everyone please confirm. Am I audible? Am I visible clearly to all of you? Audio video is clear to everyone. Very good. How are you all? Audio video is clear to everyone. Very good. How are you all? How are you all? Good evening everyone. How are you all? So I hope you all are good and preparing well for your exam. Yes. I hope you all are good and preparing well for your exam. And I'm also hoping for the same that you have completed the PYQs for the topics that we have already discussed or covered in the class. So please let me know in the chat box, have you completed the GATE and ESE PYQs for the chapters, for the topics that we have already covered? Have you completed all the question discussion? Yes or no? Let me know in the chat box. So till now you have not completed. Good evening, good evening, good evening to all of you. Good evening to all of you. So beta, please try to manage the time. I know sometimes due to your college semester exam, it is difficult. I can agree. I am agreeing on this point, but ultimately we have to manage. Yes or no? It's our preparation, it will be our result. So for that you have to put your efforts and try to manage, and definitely you can manage, trust me. If you want to manage, definitely you can easily manage, trust me. So in the last class we have completed the basic construction detail of the theodolite. So what are the various components of the theodolite from the construction point of view? What were their uses that we have also covered? Yes or no? Main part was the telescope. In telescope, two main functions were there. One was the eyepiece and another was the objective piece. In the case of eyepiece, there was a diaphragm. In the case of eyepiece, near to the eyepiece, there was a diaphragm where two crosshair were provided. So whenever we have to take any reading, we have to take any measurements, always we will take the reading corresponding to the intersection of those crosshairs and the staff. And if I talk about the objective lens, so in the case of objective lens, with the help of the objective lens, you can sight the object. Yes or no? So with the help of theodolite, if we talk about the measurements, so we can measure the horizontal angle, we can measure the vertical angle, and both these measurements were direct measurement. Directly we can measure the horizontal angle, directly we can measure with the vertical angle with the help of the theodolite. Some more work, some more measurements we can also perform with the help of the theodolite, like we can do leveling work. That means we can take the staff readings with the help of the theodolite. Yes or no? because the main part of the theodolite and the main part of our level instrument was telescope. So we can take the staff readings also, and if we take the staff readings, we can perform the leveling work. We can find out the RL. For that we have discussed two methods, or you can say various methods. So in the case of plane leveling, we have discussed about the HI method and rise and fall method. In the case of geodetic leveling, we have discussed about the reciprocal leveling also. Yes, we have also discussed the concept of the inverted staff. So all those readings, all those measurements, all those calculations you can perform if you can collect the reading with the help of the theodolite. And yes, with the help of theodolite we can collect the reading. For prolonging a line we can use the theodolite. Yes, कल का वीडियो अपलोड नहीं हुआ. Okay, so I will communicate this message to the technical team, and if the video is not uploaded yet, very soon it will be uploaded, don't worry. So I will forward this message to the technical team. I will forward your concern, and very soon you will get the video, don't worry for that. Okay. So I hope you all have attended the previous class. Now we have some different objective. Now we are going to discuss some important thing, important method, important instrument for the collection of the data in the special situations. So in the today lecture, I will talk about the tacheometry. So if you remember in the chapter number 1 on the classification of surveying, so we have classified the surveying based on the methods used. Do you remember this point? So we have classified the surveying based on the purpose, based on the objective, based on the method, and based on the place where we are performing the measurements. So if I talk about the based on the methodology, we have classified the surveying as traverse survey. So now I think you all are comfortable. What do you mean by the traverse survey? So what is the traverse survey? How we can take the measurements and how we can collect the data with the help of the traverse survey. All these points we have covered in this course as of now. Similarly, we have classified the surveying based on the methodology that was the triangulation survey. That was the triangulation survey. And yes, we have also discussed about the triangulation. What will be the condition for the well-conditioned triangle? What will be the condition for the ill-conditioned triangle? All these points we have also covered. And the next classification was trigonometrical surveying. The next classification was trigonometrical surveying or the trigonometrical leveling, where we were supposed to use the basic concept of the trigonometry to find out the linear measurement, to find out the angular measurement. And I think now we can confidently say this, yes, we are comfortable with the trigonometrical leveling. So we have discussed 3 cases in the case of trigonometrical leveling: case 1, case 2, and case 3. And if you have attended the previous class, if you have attended the last class, so I have discussed that in this GATE 2023, there was a direct question. There was a direct question related to the case 2 in your GATE exam. That concept we have covered where we have placed the instrument in 2 positions. The condition was we can measure the distance, horizontal distance between the instrument position, but we were unable to measure the distance between the instrument and the objective. The instrument and the object, yes or no? So that was our case 2 problem where 2 unknowns were there. One was the horizontal distance and one was the vertical distance. And we know to solve the 2 unknowns we required 2 equations. To solve the 2 unknowns we required 2 equations, yes or no? And for 2 equations we have measured 2 vertical angle from the 2 position of the instrument. I hope you all can easily recall all these points. Are you able to recall all these points related to the case 2 of the trigonometrical leveling? Are you able to recall all these points? Tell me in the chat box. Tell me in the chat box, are you able to recall all these points related to the case 2 of the? Very good, very good. So you can attempt that question. You can attempt that question in the GATE 2023 exam. Okay. And the next discussion, next classification we have done of the surveying, that was the tacheometry survey. तो So as of now, we don't know anything about the tacheometry survey. But after this class, you will have clear understanding about the tacheometry survey. So what we are going to discuss in the class, I hope this point is clear to everyone. So in the today's class, I will talk about the basics of the tacheometry. What is tacheometry? When we will use the tacheometry? What is the procedure of the tacheometry to collect the data? And with the help of the tacheometry, what actually we can find? And multiple time we have discussed in the class itself. In the case of entire surveying, the objective is still same, to define the position of any point. And you can define the position of any point with the help of certain linear measurement or with the help of certain angular measurement, or both. Yes or no? Linear measurement is related to the distance. So to defining the position of any point, we can take the measurement of the horizontal distance, we can take the measurement of the vertical distance. Similarly, we can measure the angles in the case of angular measurement, and we can measure the horizontal angle or we can measure the vertical angle for defining the position of any point. Yes or no? So our objective is still same. That means you can say whatever we have discussed till now, from the objective of the surveying point of view, all that discussion is valid for the tacheometry also. So for linear measurement, we have discussed about the various methods and the various instruments. Yes or no? Similarly, for the angular measurements, we have discussed about the various methods and various instruments. Why? Any one of you who want to tell? Why we have discussed the various methods, or why we have discussed the various methods or instrument for measuring the same thing? For measuring the yes, as per our requirement, we can opt any method, we can select any instrument. It will totally depend upon our requirement, our conditions, our resources. Yes or no? Our availability of the resources. Absolutely right. Absolutely right. So now I am providing you a condition. Just wait, just a minute. So now I will provide you a condition, a situation, and you all need to answer. So you must have visited some hill stations. Have you visited hill stations, yes or no? Have you visited hill stations, yes or no? You must have visited some hill stations. Tell me in the chat box. So let's take a condition. So in this class, we will cover the discussion. What is tacheometry, methods of the tacheometry, tacheometric equation, and the distance and elevation. How we can find out the distance and elevation with the help of the tacheometry, or you can say with the help of the tacheometer. Let's try to understand this situation. So for example, this is somewhere this is the hilly situation. These are the hills. Okay, so now you can just imagine these are the hills. Let's say this is the point A and this is the point B. Now I want to measure the horizontal distance between the point A and B. Now I want to measure the horizontal distance between the point A and B. Whatever we have discussed till now, if I talk about the horizontal distance measurement, so we have discussed about the chain, we have discussed about the tape. We have discussed about the chain and we have discussed about the tape. Can we measure the distance where the situation is like this? These are hills. And we want to measure the distance between the point A and B. More precisely, we want to measure the horizontal distance between the point A and B. So tell me, can you measure this horizontal distance between the point A and B with the help of the chain or tape? with the help of the chain or tape? Obviously, answer will be no. But this is not the solution for our problem. If we need to measure, if we need to define the distance between point A and B, so with the help of any method, with the help of any instrument, we have to measure this distance. We have to measure this distance. So if I am saying, yes, you can measure this distance, and very easily you can measure this distance as compared to the chain or tape. If we will try to measure this distance with the help of the chain or tape, almost it is next to impossible. Yes or no? But very easily, in very quick time, you can measure the horizontal distance between the point A and B. How? That we want to learn. That we want to understand how. So this method tacheometry is going to be suitable for those area, for those field, for those terrain where we cannot measure the distance between the points with the help of the chain or tape, like the situation like this. In the case of hilly area, it will be difficult for us to measure the distance with the help of the chain or tape. On these situations, we have one best method to measure the horizontal distance, or you can say to measure the elevation of any point. With the help of the tacheometry, you can perform the linear measurement as well as you can perform the angular measurements also. Only these two measurements are required to define the position of any point, that we have already discussed multiple times. Yes or no? That we have already discussed multiple times. So now I think after this discussion, this point is clear to everyone. This point is clear to everyone where we are going to use the tacheometry. So if I talk about the suitability, of the tacheometry, where it is going to be suitable, I hope now this point is clear to everyone. Okay, so now let's move further. We can easily measure the horizontal distance between the point A and B with the help of the tacheometry. Now the question is how we can measure the distance. So obviously, like in the case of chain survey, which instrument we have used for the linear measurement? In the case of chain survey, which instrument we have used for the linear measurement? So we have used the chain or tape. In the case of compass survey, which instrument we have used for the measurement of the bearing? So we have discussed about the prismatic compass and surveyor compass. Similarly, if we talk about the leveling, if we want to find out the reduced level, so for measuring the staff readings, we have used the auto level. Yes or no? So in every method of the leveling, definitely one instrument is required. In every method of the leveling, for the collection of the data, one instrument is required. Like in the case of trigonometrical leveling, we required some angular measurement device. For that we have used the theodolite for measuring the vertical angle. And we also required a linear measurement. Yes. So with the help of the tape, we can measure the horizontal distance. So, which instrument we are going to use in the case of tacheometry? Which instruments we are going to use in the case of tacheometry? So the main instrument that we are going to use will be the tacheometer. The main instrument which we are going to use will be the tacheometer. Have you seen tacheometer? Any one of you? Have you seen the tacheometer? You want to see the tacheometer? You want to see the tacheometer, yes or no? You want to see the tacheometer? You have already seen, don't worry. You have already seen. So yesterday we have discussed about the theodolite. Yesterday we have discussed about the theodolite. You all are familiar with the basic construction detail of the theodolite, yes or no? You all are familiar with the basic construction detail of the theodolite. I don't think any one of you is having the problem. Okay. Tacheometer is nothing. What do you mean by sir nothing? Tacheometer. If I want to define the tacheometer, tacheometer is a special type of theodolite. Fitted with stadia. Tacheometer is a special type of the theodolite fitted with stadia. Sir, we know about the theodolite, but this term is totally new for us. That is stadia. That is stadia. Yes or no? You must have problem with the stadia. So what is this stadia and what is the use? What is the use of this stadia? Okay, let's see. Okay, let's first talk about the theodolite. Let's first talk about the theodolite. If I talk about the theodolite, yesterday we have discussed some basic construction detail. Yesterday we have discussed some basic construction detail of the detail of the telescope. So it was like somehow it was like your telescope. Yes or no? If I talk about the telescope, one was the eyepiece. One was the eyepiece, something like this, and another was the objective lens. Another was the objective lens. This was the two components in the case of theodolite. One more part we have discussed somewhere here close to the eyepiece. Close to the eyepiece, there was a crosshair diaphragm like this. In the case of theodolite, there was a diaphragm like this, where two crosshair, these are the crosshair. These are the crosshairs. Two crosshair were there, one was horizontal, another was the vertical. So for example, this is our staff. For example, this is our staff. So let's say these are the graduations. These are the graduations where we will take the staff reading. With the help of this telescope, which reading we should take if I want to take the staff reading. So I will take the staff reading. I will take the staff reading corresponding to the intersection of the crosshair. So I will take this reading. Yes or no? I will take this staff reading. This was the use. That's why. Yes, that's why we have provided the diaphragm near to the eyepiece. This was the discussion related to the theodolite, and no one is having the problem in this situation. There was the eyepiece, there was the objective lens, there was a diaphragm. In the diaphragm, there was two crosshair. One was the horizontal crosshair, one was the vertical crosshair, and we can take any staff reading corresponding to the intersection of these crosshair, and on the staff where we will get the reading, we can take the reading. This was a simple construction detail of the theodolite. Now what I will do, listen carefully. If I am providing two more marking, just in a very simple language I can say, let's say that this is the situation, one marking is there, this is the. Now what I am doing, I am providing two more marking like this. Two more marking like this. So if I talk about the another view, so you will get a marking like this and you will get a marking like this on the diaphragm, yes or no? One above the intersection and one below the intersection, we have provided two more marking. And because these are nothing but This is your upper stadia. This marking is your upper stadia, and this is your lower stadia. This is your lower stadia, and that was the already intersection point that we can consider as this is your axial stadia. This is your axial stadia, and the spacing between these two additional marking, the spacing between the upper stadia and lower stadia, we can represent with the help of the small I. Small I is the stadia interval. Small I is the stadia interval. Small I is the stadia interval. As we have provided these two stadia, as we have provided these two additional stadia, now this theodolite will be known as, now this theodolite is known as tachyometer. So that's why we have written this statement. That's why we have written this statement that tachyometer is a special type of the theodolite fitted with the stadia. Now, I think you are familiar with this instrument, that is the tachyometer. Sir, I have some doubt. Sir, I am having some doubt. With the help of the theodolite, we were not able to measure the horizontal distance directly. Yes, if I talk about the angular measurement, horizontal angle, if I talk about the vertical angle, that we can measure with the help of the theodolite. But just by providing these two marking, just by providing these two stadia, now you are saying we can measure any horizontal distance, and that too very easily. Sir, how? That should be your query. Do you have the same query? What happened? What happened exactly? Just by providing these two marking, now with the help of this instrument, we can measure the any horizontal distance. We can measure the any horizontal distance. Yes, you can measure. You can measure the distance, you can measure the horizontal distance, you can measure the inclined distance also. You can measure the inclined distances also. So do you want to understand how we can measure the distance? Do you want to understand what is the game? Just by providing these two marking or these two stadia, now how very easily we can measure the distance? Do you want to know? Let me know in the chat box. Tell me in the chat box. Do you want to know? Do you want to know? Okay. So you want to know, huh? For that we will discuss some basic theory of the tachyometer. For that, first we will discuss some basic theory of the tachyometer. Let's see. So tell me one thing. When now the diaphragm is something like this. Now the diaphragm is something like this. How many staff reading you will get now? So if this is the staff and this is the situation of the diaphragm. So can we say in the case of theodolite we were getting only one staff reading? In the case of theodolite we were getting only one staff reading, and that was corresponding to the axial stadia. Yes or no? That staff reading in the case of theodolite we were getting corresponding to the axial stadia. Now as we have provided two more marking, can I say now I will get 3 staff readings? Now I will get 3 staff readings. Tell me yes or no. Which point you missed? Ria. In the case of theodolite, there were no stadia. Consider these two separate instruments. One is theodolite, another is the tachyometer. One is the theodolite, one is the theodolite that we have just discussed. You just told me, ki sir, with the help of the theodolite, we will get the one staff reading. See your comment. You have answered this question already, ki sir, we will get one reading corresponding to the intersection of these two cross here. Yes or no? Yes or no? So now if the in the case of tachyometer, now this is tachyometer. Now in the case of tachyometer, if there are three markings like this, one is upper stadia, one is lower stadia, and that we have termed as the axial stadia. Now I will get the three staff reading, yes or no? Now I will get the three staff reading. Let's say something like this. Just we will have the discussion in detail, don't worry. In actual practice, you will get the staff reading. So this is going to be the, this will be the staff reading corresponding to the upper stadia, and this will be your reading corresponding to the lower stadia. That is the separate discussion. So can I say now I am getting three staff reading S1, S2 and S3? Yes or no? Now I will get three staff reading on the staff S1, S2 and S3. Yes or no? Now I will get three staff reading, and that reading we can represent as S1, S2 and S3. Everyone please confirm in the chat box how we are getting the three staff reading. This point is clear to everyone? How we are getting the three staff reading with the help of the tachyometer. This point is clear to everyone? One staff reading we will get corresponding to the upper stadia. One staff reading we will get corresponding to the lower stadia. One staff reading we will get corresponding to the axial stadia. In this way, now with the help of the tachyometer, total three staff readings we will get. So can I say the difference between the S1 and S3, the difference between the S1 and S3, that we can represent with the help of simply S. Reading should taken in the same level. Because this is your staff. This is your staff. Whatever reading you will get, that will depend upon the distance between the staff and the instrument. So this is the staff. If we are very close to the staff, obviously we will get the three reading. When we will change the distance between the staff and the tachyometer, this staff readings will change. How they will change, that we will discuss. Don't worry. So all the readings we are getting on the same staff. The important discussion is we will get the three staff reading if we are using the tachyometer. We will get the three staff readings if we are using the tachyometer. This is the point. The discussion till now is clear to everyone. Everyone please confirm in the chat box. If the discussion till now is clear to everyone, till now we have discussed where we are going to use the tacheometry. What is tacheometry? What is the tacheometer? And what is the changes, or you can say the difference between the theodolite and the tacheometer. These points we have covered till now. These points we have covered till now. I hope the discussion till now is clear to everyone. For that you need to understand the theory of the tacheometry. That we will also discuss. Why we are getting the staff reading corresponding to the upper stadia we are getting the lower reading. Corresponding to the lower stadia, why we are getting the higher reading. For that, we will discuss the theory of the tacheometry. Don't worry. As of now, just try to understand this simple point. We are going to get the 3 staff readings if we are using the tacheometer. If we are going to use the tacheometer. So, whatever will be the difference between the S1 and S3, whatever will be the difference in the reading in the S1 and S3, that we can represent with the help of S, and this S is nothing but, for that we will use the term staff intercept. For that we will use the term now staff intercept. So what do you mean by the staff intercept? It is the staff readings corresponding, it is the difference of the staff reading corresponding to the upper and lower stadia. Corresponding to the upper and lower stadia. I hope this point is clear to everyone. I hope this point is clear to everyone, yes or no? Tell me in the chat box. Tell me in the chat box. What about others? Why others are not commenting? Everyone do comment in the chat box, dear. If you all are going to interact, obviously the discussion will be more effective. If you all will interact, the discussion will be more effective. So can we proceed further? Can we proceed further? So, you need to remember these two terms. You need to understand these two terms. One is small I. What was the small I? Tell me in the chat box. What is small I and what is S? You should have clear understanding about these two terms. You should have clear understanding about these two terms. So what do you mean by the small I and what do you mean by the S? Small I was stadia interval. Small I was stadia interval. This is your small I. Small I was stadia interval and small s is the difference of the staff readings corresponding to the upper and lower stadia. Yes. Yes, very good. So now you can understand the theory of the tacheometry and let's see the discussion. So whatever we have discussed till now, all the points are mentioned here. Tacheometer is a special theodolite with 3 horizontal lines. With 3 horizontal lines in the crosshair through which 3 different staff readings are taken. Through which 3 different staff readings are taken. The main advantage of this instrument that we can determine the horizontal distance as along with the elevation. So, in the case of undulated or uneven area, with the help of this method, or you can say with the help of this instrument, we can measure the horizontal distances as well as we can define the elevation. So tacheometry is defined as an optical distance measurement method. Tacheometry is defined as an optical distance measurement method. The other name given to the tacheometry are tachymetry or telemetry. As compared to the chaining on the flat ground, the accuracy of the tacheometer distance is low. but on a rough and steep ground, accuracy is more. So if I talk about the accuracy, so if you are taking the measurements in a plane, in a simple field, obviously the accuracy of the tape measurement, or you can say any direct method that we are using, accuracy will be more. Yes or no? That we have already discussed. For any quantity, if we are measuring that quantity directly, the chances of accuracy will be more. But if I talk about the undulated area, like in the first slide itself, I have considered a situation like hill. At that situation, if you go for the direct measurement, obviously there will be high chances of the error. There will be high chances of the error, yes or no? There will be high chances of the error. So that's why we have discussed. We are discussing about the various methods. We are discussing about the various instruments based on their merits and demerits, advantage and disadvantage. We can select any method, yes or no? We can select any particular method. So now let's move further. So all these points we have already covered. What is tacheometry, what is tacheometer, and where we are going to apply the tacheometry. So various options are there. We have discussed about this case. So this is your upper stadia, this is your lower stadia, and this is your axial stadia. And one more term that I have already introduced, and that was small I. Again I am repeating this point. Small I is the stadia interval. Small I will be the stadia interval. Small I will be the stadia interval. Clear? And corresponding to the staff reading, whatever staff reading we will get, it is the difference of the staff readings corresponding to the upper stadia and lower stadia that we can represent with the help of S, and S is nothing but staff intercept. S is nothing but staff intercept. So these two terms are clear. Okay. Various staffs are there. Let's move to the main discussion. Let's move to the main discussion. Let's talk about the theory of the tacheometry. This is the important discussion. This is the important discussion that is related to the theory of the tacheometry. Let's see. In actual, this is the tacheometer, but we are only considering the main part of the tacheometer, and that is the telescope. That is the telescope. So we are not representing the various other components, various other elements of the theodolite or the tacheometer here. Our main point of interest is that is the telescope, because whatever measurements we will take, whatever staff readings we will take corresponding with the help of the telescope only. Yes or no? All the measurements we are going to perform. So this is let's say a tacheometer. From understanding point of view, I have considered the telescope here. Let's see. So in general, if I talk about this is going to be the upper stadia, this is going to be the lower stadia, axial stadia, and you will get the staff reading something like this, and this is the staff intercept, and this would be equal to S3 minus S1. This would be equal to S3 minus S1. Let's see. Corresponding to the upper stadia, you are getting the reading as S1. I hope you all can see the diagram. Corresponding to the upper stadia, we are getting the reading on the staff, that is S1. Corresponding to the lower stadia, we are getting more staff reading, that is S3. We are getting more staff reading, that is S3. Let's see how. And you already know. You have discussed all these basic points. Just you need to recall all these points. You will able to recall very easily. So let's try to understand this situation. So this diagram is very important. What will happen? So this is your upper stadia, this is your lower stadia, this is your axial stadia, and this is the distance I. Stadia interval. This is your objective lens. So how the image will form? How the image will form? So I will introduce various terminology here, and you can solve any question related to the tacheometry if you are familiar, if you are comfortable with the terminology that we are using. And this is very easy discussion, so don't worry for that. Just listen carefully. You will able to get all the points. You will able to get all the points. So this is your objective lens. So obviously one ray will pass from here. We are going to see how the image will form. So first it will move like this. Yes or no? Due to this lens. Due to this lens, this will be the path. Yes or no? Similarly, from this point, this is going to be the path, or this is going to be the situation. Yes or no? And we also know two races are going to pass from the focus point, of the objective lens, and where these two lines are going to intersect, we will get the staff reading. Yes or no? And I hope you can easily recall all these discussion. I hope you all can. So let's see, corresponding to the upper stadia, which reading you are getting? Tell me in the chat box. Corresponding to the upper stadia, where you are getting the reading on the staff. Corresponding to the upper stadia, which reading you are getting on the staff? Yes, that is S1. Corresponding to the lower stadia, which reading you are going to get on the staff? Corresponding to the lower stadia, which reading you are getting on the staff? S3. This is going to be the, can I say, a small f, I can represent this is going to be the focal length of the objective lens. You are able to see the object, you are able to sight the object just because of this objective lens, na? Just because of this objective lens. Yes or no? So if this is the objective lens, there must be a focal point, and this is going to be the focal length, and that focal length we are representing with the help of the notation small f. Let's see. Now we are introducing some, we have already introduced I, we have already introduced S. Now one more term is we have introduced, that is the small f. Small f is the focal length of the objective lens. Small f is the focal length of the objective lens. Let's say capital D. Let's see, refer the diagram. Can I say capital D is the distance between the tacheometer and the staff? Tell me. Capital D is the distance between the tacheometer and the staff. Can I say like this? Capital D is the distance between the tacheometer and the staff. Okay. One more term is there, that is the small d. Listen carefully. Listen carefully. Small d is the distance. Small d is the distance from the center of the tacheometer, or you can say from the center of the telescope. From the center of the telescope to the objective lens. From the center of the telescope or the tacheometer to the objective lens, and that distance we are representing with the help of the small d. That distance we are representing with the help of the small d. That distance we are representing with the help of the small d. I hope the point is clear to everyone. I hope the point is clear to everyone, yes or no? So now we are familiar with the small d. I think these things are going to sufficient. Okay. You already know. You already know these two terms V and U. You already know these two terms V and U. Distance between the eyepiece and objective piece. Diaphragm It is the distance between the diaphragm and the objective lens. It is the diaphragm. It is the distance between the diaphragm and the objective lens, and that distance we are representing with the help of the small v. Small u is the distance between the objective lens and the staff. Small u is the distance between the objective lens and the staff. So listen carefully. I am repeating all the points one again. I is the stadia interval. If you have any doubt, any query at any point or at any term, you can ask your doubt, you can ask your query. Again and again, I am repeating the same thing for the better understanding of the tacheometry. This theory of the tacheometry you should know. This theory of the tacheometry that you should know. Any doubt to anyone? So now listen carefully. I is the stadia interval, S is the staff intercept, F is the. Can you explain how can we get the upper stadia reading at S1, sir? Dear, how the image will form? I hope you in your basic schooling you must have understand how the image will form with the help of the objective lens. How you will able to sight these points on the eyepiece. So one ray will pass from the focal length, from the center of the objective lens, yes or no? And one ray will pass from the focal length. That will be, these two rays are going to be parallel. Where these two point rays are going to intersect, then you will able to sight these 2 points. Swati. Then you will able to sight these 2 points, S1, S2, S1 and S3 on the staff. So you must have, you are, I think now you are able to recall the basic physics. Yes or no? And those same concept we are using here. Those same concept we are using here. We are not just applying those concepts. Now it's clear? Yes or no? So let's understand the application point here. So this is going to be the I stadia interval. S is the staff intercept. F is the focal length of the objective lens. D is the distance between the telescope, or you can say the distance between the tacheometer and the staff. This is our main interest. This distance we want to find. This is the distance that we want to find with the help of the tacheometer, yes or no? Capital D is the distance between the staff and the instrument that we want to find with the help of the tacheometer. You will able to find, don't worry. Small d is the from the center of the telescope to the objective lens. From the center of the telescope to the objective lens, this is the distance that we are representing with the help of the small d. This is the distance that we are representing with the help of the small d. U is the distance from the objective lens to the staff. U is the distance from the objective lens to the staff. V is the distance from the diaphragm to the objective lens. From the objective lens to the diaphragm, this distance is small v. I want confirmation from all of you. All these points are clear to everyone? All these points are clear to everyone, yes or no? Let me know in the chat box. All these points are clear to everyone? Okay. So now we can go for the basic theory of the tacheometer, and this is very simple, you can understand. I hope you all have remember this equation. For the objective lens we can write 1 upon f will be equal to 1 upon u plus 1 upon v. Yes or no? Confirm in the chat box if you are familiar with this equation, lens equation. If you are familiar with this lens equation, can I write 1 upon f will be equal to 1 upon u plus 1 upon v? Tell me. From the simple similarity, can I write, listen carefully, can I write I by v? Can I write this I by v? It is going to be equal to, it should be equal to s by u. Can I write like this? Tell me. Okay. Can I write I by v should be equal to s by u? How? So this is your I, let's say. This is your s. This distance is u and this distance is v. Now can I write like this? This I by u, this I by v, so this is v. This is v and this is u. Now I hope you got. So can I write this I by v should be equal to s by u? Tell me. Okay. So from here can I find out the value of, 1 upon v? So 1 upon v will be equal to, this is going to be s upon ui. 1 upon v should be equal to s upon ui. Now, in this equation, can I replace the value of 1 upon v? So 1 upon f is equal to 1 upon u plus 1 upon v, and from equation A, 1 upon v will be equal to s upon ui. S upon ui. Tell me, dear. Tell me yes or no. Just rearrange these terms. Just rearrange these terms. I have taken 1 upon u as a common, 1 plus s upon I. From here I have found the value of u. U is going to be f, 1 plus s upon I. Just I have rearranged these terms. What I have written? F plus f will be multiplied by the, we are going to multiply f on the inner side. So what we will get? 1 plus f upon is. Can I write the same equation like this? Yes or no? From here can I find out the value of u? Tell me. From the diagram, just try to understand. From the diagram, what is this capital distance d? What is this capital distance d? So I can write this capital distance d will be equal to nothing but a small d plus u. This capital D is nothing but a small d plus u. Can I write like this? Okay. So now you know the value of u. Now you know the value of u. So d will be equal to u plus d. So u I can write f, 1 plus s upon I plus d. Can I write like this? Tell me. Can I rearrange this equation? D is equal to, so this is going to be f upon I into s plus f plus d. Can I rearrange this equation like this? Tell me. Can I finally write this equation like this? D will be equal to f upon I into s plus f plus d. All those terms are same, just we have rearranged this equation. Just we have rearranged this equation. Can I write the final form of this equation like this? Can I write the final form of this equation like this? Just cross check and tell me in the chat box. Everyone, just cross check and tell me in the chat box. Can I write the same equation like this? And if you don't have, what is this f? F is the focal length of the objective lens. F is the focal length of the objective lens. What is this I? I is the stadia interval. I is the stadia interval. Can I say the f upon I value I will get, that is going to be the constant? And if you don't have any problem, I can say this is going to be the multiplying constant. Tell me. Similarly, what is this distance? What is this distance? F plus D. F is the focal length. D is the from the center of the telescope to the objective lens. D was the distance, but from the center of the telescope, obviously F plus D is also going to be constant. And if you don't have any problem, can I say this is going to be the additive constant? This is going to be the additive constant. So if you don't have any problem, can I rearrange this equation like this? So I can also write D is equal to Ks plus C, where K is your multiplying constant and C is your additive constant. Can I write D will be equal to Ks plus C? K is your multiplying constant and C is your additive constant. K will be equal to F upon I and C will be equal to F plus D. And this is the main equation. This is the main equation and this is known as the Tacheometry equation. This is known as the Tacheometry equation. So now let's see the application of this equation. That is very important part. If you want to find out the distance between the instrument and the staff, what are the various things that you required? What are the various things you required to find out the horizontal distance between the point A and B? So to apply this equation, we want the value of K, and that is nothing but multiplying constant. We want the value of K, yes or no? We want the value of S, that is the staff intercept, and we want the value of C, that is the additive constant. Can I say for any tacheometer or for any telescope, every instrument comes with their specification? Every instrument comes with their specification, yes or no? Every instrument comes with their specification. So can I say, if you know the value, if you know the constant, these two constant for any tacheometer like K and C, just by taking the staff intercept, simply you need to take the 3 staff readings with the help of that telescope, and you can take with the help of the upper staff reading and the lower staff reading, you can find out the value of S. Just put the value of S. If you know the value of multiplying constant, additive constant for the instrument, very easily you can calculate the distance between the instrument and the staff with the help of this equation. With the help of this equation, yes or no? So just by taking the staff readings. Now with the help of this equation, we can also define the distance between the staff and the instrument. I hope now you got the understanding about the tacheometry. Yes or no? Any doubt to anyone? Any doubt to anyone? How we can use this tacheometric equation to find out the distance between the staff and the instrument? I hope this point is clear to everyone. Yes or no? Please confirm in the chat box. We will also discuss how we will get this value of k and c, how we can define this distance, how we can define these constant, multiplying constant and additive constant. Don't worry, for that we will have the discussion. I hope the discussion is clear to everyone. I hope the discussion is clear to everyone. No doubt, very good. Now let's move further. So this is going to be your additive constant that we are representing with the help of C, and K we are representing with the help of multiplying constant, that is going to be F upon I. That is going to be F upon I. We have discussed all these points. Now there is a node point. Now there is a node point. A telescope which is having the value of K as 100 and C as 0. A telescope which is having the multiplying constant as 100 and the additive constant as 0. And the additive constant as 0 is known as analytical telescope. Is known as analytical telescope. So these are the specification you should know. Any telescope for which the multiplying constant is 100 and the additive constant is 0 will be known as the analytical telescope. So do remember this specification of the analytical telescope. Do remember these specifications related to the analytical telescope. It can be depend upon the value of F and D. It can be, dear, plus minus. If one is positive, one is negative, having both are having the same magnitude but opposite nature. So what will be the summation of F plus D? What was the C? C was F plus D. Yes or no? If both are having the same magnitude but natures are opposite. So we should know this specification of the analytical telescope, that for the analytical, simply we can say, for the analytical telescope, the multiplying constant is going to be 100 and the additive constant will be equal to 0. But all the telescope we are using may not have the analytical telescope. Yes or no? It is not compulsory that whatever telescope we are using, that is the analytical telescope. Main point of interest is, sir, how we will able to find these constant? How we will know about these two constant? Because we can use this equation D is equal to Ks plus C once and only if we know the value of K and C. If you don't know the value of multiplying constant, if you don't know the value of the additive constant, how many staff readings you can take? You cannot define the distance. Yes or no? That is the very important discussion from your exam point of view. That is the very important discussion from your exam point of view. Listen carefully. So here two situations are there. I will talk both situations. So you can say condition 1. Let's say this is the first condition and we will discuss one more condition. Let's say we will discuss about the condition 2 also. Both the conditions, both the situation that we can face, I am discussing about that. I am discussing about that. If I want to find out the value of K and C, we know K is equal to F upon I and C is equal to F plus D. What is this F? What is this I? What is this D? That we have already discussed. Don't you think F, I and D are nothing but these are the specification. So whatever telescope you are bringing from the market, whatever instrument you are purchasing from anyone, you will definitely have the specification of that instrument. Yes or no? Yes or no? You will get all the specification from the manufacturer. You will get the all the specification from the manufacturer. Yes, but this is the tacheometer. For this, the focal length is having particular value. Stadia interval is having the particular value. And D, from the center to the objective lens, this is the instrument. For this, you know the value of D. So if we know the value of F, I and D, in that case, do you have any difficulty? Do you have any problem to find out these two constant K and C? Tell me. If you know all these specifications, if you know all these specification about the instrument, I think you can easily find out the value of multiplying constant and the additive constant with the help of these known values, yes or no? With the help of these known values, yes or no? Tell me, K will be equal to F upon I. We know the value of F. We know the value of I. It is going to be the K. C is going to be the F plus D. We know the value of F. We know the value of D. We will put the value here. We will get the value of C. So in this case, we can very easily find out the value of K and C. And once we know the value of K and C, once we know the value of K and C, can we apply this tacheometry equation to find out the distance between the staff and the instrument? Between the staff and the instrument, yes or no? Everyone confirm in the chat box. Everyone confirm in the chat box. If we can find out, if we know the value of K and C, then we can easily find out the distance between the staff and the instrument. Then we can easily find out the distance between the staff and the instrument. I want confirmation from all of you if the discussion till now is clear to everyone. If the discussion till now is clear to everyone, please confirm in the chat box, beta. Please confirm in the chat box. So this is the situation. So you can expect a question from this condition. So in the question, they will provide you all the value F, I and D. They will provide you all the staff readings corresponding to the upper stadia, corresponding to the lower stadia, corresponding to the axial stadia. They will provide you all the staff readings. With the help of the staff readings, we can easily find out the value of S. And if these values are given in the question, we can find out the value of K and C. So in that case, we can calculate the distance between the staff and the instrument. In that case, we can calculate the distance between the staff and the instrument, yes or no? We can calculate the distance between the staff and the instrument. Tell me, beta. Tell me. Okay. So now we will discuss about one more condition. Let's say these F, I and D are unknown. Let's say this F, I and D are unknowns. We don't know the value of F. We have missed all these specifications. Let's say this may be the situation. We have missed all these specifications. We don't have any specification about the tacheometer or about the telescope. Now can you find out the value of the multiplying constant and the additive constant? Tell me. Now you can find out the value of the multiplying constant and additive constant? Because without those constant we cannot find out the distance. So do you have any idea, any option in this situation? If we don't know the value of F, if we don't know the value of I, if we don't know the value of D, can we also, in this case also, can we find out the value of K and C? What do you think? What do you think? Tell me. Is this possible or not? If we don't know any specification, in this case, so Riya is saying we can't find. We can find. We can find. Without knowing these specification, for any particular tacheometer or for any particular telescope, we can find out the value of K and C. Let's see how. So in this case, you need to simply do a simple test. So what you will do, you will take a tacheometer. You will take a tacheometer. In the step 1, what you will do? You will measure a horizontal distance between the point A and B. This distance is known to you. This distance, let's say this distance is D1. We will take any 2 points A and B, and the distance between those points A and B are known to me. That distance is fixed. No problem. Yes or no? Simply that we have defined the 2 point A and B, and with the help of the tape we have measured this distance D1. Now what I will do, I will place tacheometer at point A and we will place the staff at point B. So as you know, here also you will get 3 staff readings, something like this. So this is going to be your staff intercept, and let's say this is going to be S1. Let's say this is going to be S1. So D1 is also known to us and S1 is also known to us. Now what we will do, in the same, with the help of the same tacheometer, what we will do? So I will change this distance. Let's say now I am considering this distance as D2, and D2 is also known to me. I have just changed the distance between the point A and B. Now we are having the distance D2. Now we are having the distance D2. Tell me, dear, when you will change the distance between the staff and the instrument, the staff intercept will remain same or change. As the distance is changing, this staff intercept S1 will remain same as previous value, or it will change. Tell me, what do you think? This staff intercept will remain same or change? As the distance between the staff and the instrument is now changed, undoubtedly we can say, yes, definitely sir, it will change. Definitely, but here also we will get the 3 staff reading, and from here we can find out the value of the S2. From here we can find out the value of the S2, yes or no? From here we can find out the value of the S2. Tell me dear, we are using the same instrument. So from the step 1, can I write D1 will be equal to K S1 plus C? This is your equation number 1. Yes or no? Because we are using the same instrument for both the steps. So the value of K and C will remain same. Yes or no? The value of K and C will change if we are changing the instrument from step 1 and in step 2. We are using the same instrument, we are using the same telescope, we are using the same tacheometer. So how this K and C will change? So can I write from the step 2, this D2 will be equal to K S2 plus C? Tell me yes or no. This D2 will be equal to K S2 plus C. This D2 will be equal to K S2 plus C. Tell me in the chat box. You don't think from the equation 1 and 2, from the equation 1 and 2, we can easily find out the value of K and C. Because these D1, S1 are known. Here also D1, D2 and S2 are the known values. D1, S1. Why S1 and S2 will change? How it will not change? Why not? Why it will not change? Tell me. Huh? Obviously, dear, when you will, otherwise, from the tacheometer, for any position, for any distance, you will always get the same staff reading, same staff intercept. Tell me. If I consider your point, so as per your point, no matter at what distance we are placing the staff and what distance we are placing the tacheometer, we will always get the same staff intercept. We will always get the same staff intercept. So this is going to be the conclusion if I consider your point. And do you think this is the correct statement? Do you think? Now I think the point is clear. Please confirm in the chat box if the discussion is clear. So definitely it will change. Definitely the staff intercept will change. Can we move further? So from these two equation 1 and 2, we can find out the two unknown that are K and C. So if you don't know the specification of the instrument, then also by following these simple steps, you can define the value. You can know. You are not audible. What about others? What about others? Everyone please confirm beta audio video is clear to everyone. Everyone please confirm in the chat box. Audio video is clear. What about others? I want confirmation from others also. Swati is saying everything is fine. Ria, just refresh. Just do refresh. There may be some connection from your side because I am audible to other students clearly. I am audible and visible to other students clearly, so you can just refresh. There may be some connection issue from your side. So from both the condition, you can expect a question in your exam. I hope the discussion about these two conditions are clear to everyone. How we can find out the multiplying constant and additive constant with the help of these specification or without these specification. This discussion is clear to everyone. This discussion is clear to everyone, yes or no? So now here I will discuss a very important point. Generally, students are getting confused. They are saying, sir, there are various formulas in the case of tacheometry. There are different formulas in the case of tacheometry. There are different cases in the case of tacheometry. Sir, we don't know how we can remember all the formula. And if we are remembering all the formula, if in the exam they will change any notation, any situation, then it will be very difficult for us so that we can apply that formulas and we can get the correct answer. So here what I will suggest, I hope you remember the concept, you remember the discussion of the trigonometrical labeling, yes or no? Just we have covered the concept of the trigonometrical labeling. If I consider the different case, there will be different formulas, yes or no? But what approach we have followed? What approach we have followed? The approach was very simple. Sir, we will not remember any formula. We will not remember any formula. And without formula also, based on the given information in the question, we will try to draw the diagram. And once we are able to draw the diagram correctly, we can calculate any quantity. That was the concept that we have used in the case of trigonometrical labeling. Initially, in the beginning of the class, you have mentioned that with the help of the tacheometry, we can find out the distance as well as the elevations. So how we can find out the distance, that part I have already discussed. Now I am going to discuss how you can find out the elevations with the help of the tacheometry. You can also find out the elevation. You can also find out the reduced level. You can also find out the reduced level. But here again, so as you can see in the slides, there are different formulas. There are different formulas, as you can see. There are different cases and there are different formulas, as you can see. Yes or no? For angle of elevation, for angle of depression, when the staff is kept normal, when the staff is kept vertical, and various cases are there. But what I will suggest you, you need not to remember any formula, but this will be only possible if you have clear understanding about the basics. So what approach you want to know? Formula or the basics? Formula or the diagram approach? There may be n number of cases. Yes or no? So we cannot remember n formula. But for n cases, the concept will be remain same. For n number of cases, the concept will remain same. For n number of cases, the concept will remain same. Yes or no? So let's take a simple case. I am explaining the concept with the help of this case, and you can apply this concept for any case. You can apply this concept for any case. Let us consider a situation, and I want you all will answer in the chat box. I will tell you what are the known parameters, what are the unknown parameters, which quantity you want to define, but I want answer from all of you. How you all can easily answer. We will again use the basic concept of the trigonometry only. With the help of some linear measurement, with the help of some angular measurement, how we can find out the distance, how we can find out the RL, all those points we are going to cover. Let's see here. So dear, for example, this is the situation. For example, this is the basic situation. Somewhere here is the point A, and somewhere here, let's say, it is the point B. This is the situation of the ground. This is the situation of the ground. Now let's try to understand what we have done. We have placed the tachyometer here. Obviously, if we are talking about the leveling, so we should have a point of known elevation, and that is nothing but our benchmark. That is nothing but our benchmark. So for example, we are using the tachyometer. So kya with the help of the tachyometer, can I take this backside reading? Tell me. Obviously, you can perform the labeling work with the help of the theodolite. Simply, you need to take one staff reading corresponding to the axial stadia. You need to take, I don't know how. Which point you don't know, dear? Tell me. What is your query? Tell me. I'm not getting for which particular point you are asking this. Ki I don't know how. How we can get the backside? With the help of the tachyometer. So we will place the staff. Have you attended the leveling lecture, dear? How we can take the staff reading with the help of the auto level, with the help of the telescope? Have you followed all the lectures? So simply with the help of the theodolite, with the help of this telescope, we will place the staff at the benchmark and we will take one reading only corresponding to the axial stadia, only corresponding to this intersection. We will take the backside reading here on the staff. This is the staff that we have placed at the known point, that is the point P. Point P is the benchmark. Point P is the benchmark. Now I think the point is clear. Okay. So now let's understand this point. So for example, I have placed the staff at point B. I have placed the staff at point B, and this staff we have placed vertical. That means what will be the angle between the earth surface and the staff? What will be the angle? Yes, in the auto level there was a telescope. In the case of theodolite there was a telescope. In the case of tachyometer there is a telescope. So, but if we are doing the leveling work, that telescope should be perfectly horizontal, or that we can do with the help of the level tube. That we can make sure, that we can ensure that while taking the staff reading, the telescope should be perfectly horizontal, and that we can do. If the telescope is perfectly horizontal, if the line of sight is perfectly horizontal, we can take the staff reading corresponding to that line of sight. We can take the staff reading corresponding to that line of sight. I hope this point is clear to you. Okay. So now let's understand. I want to find out the distance, horizontal distance between the point A and B. So can I represent this is going to be the horizontal distance between the point A and B? This is going to be the horizontal distance between the point A and B. So initially our instrument and the staff was on the same plane. Whatever we have discussed in the case of tacheometry till now, in all the previous example, we have located the instrument, tacheometer and the staff on the same plane. But here the situation is not like this. Here both the points are having the different elevation. This is your point A and this is your point B. But this distance is going to be the horizontal distance. So can we take the staff reading at this point? Answer will be no, because due to the ground condition, you cannot take any staff reading at this point. Yes or no? You cannot take any staff reading on this point. So obviously, so now how you can define the horizontal distance? Okay, this is the first point. So now what I will do, I will obviously in this case, I will measure some elevation angle something like this. So I have to sight the staff something like this. I have to sight the staff something like this. So now if we are using the tacheometer, so on the staff, we will get the three readings like this. This reading corresponding to the upper stadia, this reading corresponding to the axial stadia, and this reading we are getting corresponding to the, this reading we are getting the corresponding to the lower stadia. Don't you think this angle is nothing but, this angle is nothing but angle of elevation theta? This angle is nothing but angle of elevation theta. Yes or no? This is the vertical angle. This is the vertical angle. Tell me, dear. This is the vertical angle, that is theta. Yes or no? Tell me in the chat box. From the ground, can I say this is going to be the staff reading that I can represent with the help of the S2? Or from the S3 and S1, I can easily get the value of S. From the S3 and S1, we can easily get the value of the staff intercept, and that will be S. That will be S. Yes or no? Let's say this is the inclined distance. This is the inclined distance, and that distance we are representing with the help of capital L. Listen carefully. When you have applied this equation, D is equal to Ks plus C. When you have applied this equation, D is equal to Ks plus C, two important conditions are there. Both the point A and B are at the same level, and the staff was placed perfect vertically. And the staff was placed perfect vertically. Then you can apply this equation, D is equal to Ks plus C. But in this case, that case we were just discussing, staff is placed vertical, but, or you can say the line of sight was perpendicular to the staff. The line of sight was perpendicular to the staff, but here the situation is different. But here the situation is different, as you can see. What is the situation? Staff is placed vertical, but line of sight is not perpendicular to the staff. But line of sight is not perpendicular to the staff. So dear, if you don't have any problem, so can I take the position of the staff perpendicular to the line of sight? Now this angle is 90 degree. Now this angle is 90 degree. If this is the staff intercept S, I think this is going to be S cos theta, because this angle will be theta. So this will be equal to S cos theta. Now what we can say, our line of sight is perpendicular, no problem with that. That I want to do. So can you say, now with the help of this S cos theta, we will find out the value of, we can easily find out the value of L. So L will be equal to, you can write L will be equal to Ks plus C. But here S is not simply S. Here it is going to be S cos theta plus C. This will be the value of L. Yes or no? Can I define L distance like this? ds cos theta plus C. Because here the staff intercept is not S. Here the staff intercept is S cos theta. Here the staff intercept is S cos theta. Yes or no? Here our staff intercept is s cos theta. But our objective was not to measure the L. Our objective was to define the distance d. Now listen carefully, dear. If this distance is L and this angle is theta, if you don't have any problem, can I write d will be equal to nothing but L cos theta? Tell me yes or no. If this is the L distance, this is the theta angle, so this is going to be L cos theta, yes or no? Beta, if this was the S, and this angle is theta, so let me change the color for you. If this was the S and we have to consider the line of sight perpendicular to the staff. So if this is going to be angle theta, so can I say this is going to be S cos theta, the green one? Yes or no? So if this is the distance L, this angle is theta, this will be mere lal. This will be nothing but L cos theta. So we know the value of L. Can we find out the value of D? D will be equal to K S cos square theta plus C cos theta. This is the horizontal distance. This is the horizontal distance. Now let's understand one more point. Now if I want to find out the RL of point B, can you tell me what will be the RL of point B? Now I am also talking about the elevation. Now I am also talking about the why you replaced S with the S cos theta, because beta with the where we can apply this equation D is equal to Ks plus C. We can apply what are the necessary condition, that is the point already covered. So we can apply this D is equal to Ks plus C when the point were on the same plane and this line of sight was perpendicular to the staff. Yes, I am repeating. This line of sight was perpendicular to the staff, yes or no? Then your L and D was same value. But the case we are discussing, that is the case of angle of elevation. Both points A and B are not having the same elevation. That's why this is the angle of elevation, theta is here. So we can apply the tacheometric equation to find out this L. That's it. Yes or no? Once we know the L, once we know the theta, we can define D. Or here, if we are taking the staff intercept perpendicular to the line of sight, that is not S, that is the S cos theta. This pink line. That's why for defining the L, we have considered S cos theta instead of S. Now I think the point is clear to everyone. There may be the same situation when the B point is at lower elevation as compared to the point A. Then you will say, sir, that is the angle of depression. It is not always compulsory or mandatory that point B will have the higher elevation. Point B will have the lower elevation, may have the lower elevation as compared to the point A. As compared to the point A. I hope the point is clear to everyone. I hope the point is clear to everyone now. Yes. So now if I want to find out the RL of the point B, let's see for this simple case. Again, I am not discussing any formula here. I am just providing you the basic concept with the basic geometry, how you can play with the tacheometry. You can deal any problem if your all the basics are clear, and all that basic points I am discussing in the class. So I think after 1 or 2 class we will have some PYQ discussion for whatever topic we have covered. So we are going to solve some good question from your PYQ related to those topics that we have covered in the class itself. So I think after 2 class there will be a class. You will get the detail on the planner. Okay. So we will solve one question related to the tacheometry also. And we will not apply any formula. With the help of the basic approach we will solve. And that approach I am discussing. Tell me dear, tell me, listen and see the diagram carefully. Let's see. So for example, this is your distance S2. If you don't have any problem, can I say if this distance is L, this angle is theta, so this is going to be L cos theta, and I am representing here this distance is nothing but L sin theta. Can I write like this? How we will get cos square theta? Dear, D is equal to L cos theta. This is the value of L. D will be equal to L cos theta. You need to multiply with the cos theta. Ks cos theta into cos theta will be equal to Ks cos square theta plus C into cos theta will be equal to C cos theta. Swati, have you got this point? Have you got this point? So similarly, this distance is going to be L sin theta. So can I say this is the vertical distance? So can I write this V will be equal to? Can I write this V will be equal to L sin theta? What was L? L was Ks cos theta plus C. So we can write V will be equal to L Ks cos theta plus C into sin theta. So V will be equal to Ks cos theta into sin theta plus C sin theta. Can I define the vertical distance like this? Yes or no? Yes, in this way we can. Yes, simply yes, in just D is equal to L cos theta. So wait. So this D is equal to L cos theta. I am solving here. Listen carefully. Yes. Okay. What was the L? L is going to be Ks cos theta. So Ks cos theta plus C into cos theta. Now you will get Swati. So now I can write Ks cos square theta plus C cos theta. This is going to be D. Same is written here. Same is written here. You can cross check. You can cross check. Confirm in the chat box if now you are clear with why we are multiplying the cos theta and why we are multiplying the sin theta. Okay. So now the main objective was what will be the RL of point B. Can I write? RL of the point B will be equal to nothing but benchmark. See the diagram carefully. How I can define the RL of the point B? So I can write RL of the point B will be equal to benchmark plus this backside reading plus this backside reading plus this distance V plus this distance V minus S2, and if required we will also apply some correction if the problem will be related to the geodetic labeling. Again I am repeating, this is the benchmark. We have added the backside. We reached to up to this point. Then we are adding capital V. We reached to this point, and from this point I am subtracting this distance S2. This will be equal to minus S2. Again, I am repeating, you need not to remember these cases. Whatever may be the situation, angle of elevation, angle of depression, just with the help of the basic concepts of the tacheometry and basic geometry, L cos theta, L sin theta, we can derive all the expression, or we can easily solve any question related to the tacheometry. So this was the discussion how we can find out the horizontal distance with the help of the tacheometry, and how we can also define the RL of the point with the help of the tacheometry. So I hope the entire discussion related to the tacheometry is clear to everyone. So this was the discussion for today's class. Yes, so everyone please confirm in the, this was all the concept part that we have covered. Have you subtracted correction? Yes, because the curvature correction, refraction correction will always negative. The curvature correction, what was the nature of the combined correction? What was the nature of the combined correction? So if I talk about the combined correction, it was minus 0.0673 d square. Have you got this point? Have you got this point? So I hope the entire discussion of the tacheometry is clear to everyone. So tomorrow we will discuss one more topic. Tomorrow we will discuss new topic, that is going to be the plane table surveying. So tomorrow you will have two classes as per your usual time, 7 to 9 and 9 to 9:30 to 11:30, or up to 11 depending upon the topic. So from tomorrow you will have the two classes daily, and this course will complete on the 19th of the Feb. So we are going to complete the discussion for the surveying on 19th of the Feb, and from 20th there will be the new subject in this batch. So this was all about for this class. Thank you everyone. Keep learning. Thank you.